elementary school in Friendswood. I have some incredible third graders. So for today, if you guys don't know, in a week and a half here in Friendswood, you're going to see a partial eclipse. But if you were to drive 124 miles up to the north, you would see a total solar eclipse of the sun. And that's what I'm going to talk about today. So I want you guys I want to welcome you all to KPRC2. Thank you for having me at your school. Thank you for inviting me today. I hope today is fun, and I hope you learned something. So first of all, the total solar eclipse is when the moon completely covers the sun, and we fall into the moon's shadow. This is something that is incredibly rare for it to happen. And what will happen if you're in this path of totality, you will see the sun look like that. I know many times we've glanced at the sun or kind of looked at the sun just a little bit. It does not look like that. It is just a yellow or an orange ball that hurts our eyes, and we have to kind of look away right away. But on this day, if you're in this path, it's going to look like that. But again, in Friendswood, what we're going to see is about 94% of the sun's face covered. So that is a partial solar eclipse. But if you were in North San Antonio, Austin, Cline, Dallas, Tyler, Fort Worth, Texarkana, or Del Rio, you are going to see the sun look like what I just showed you. Here's a video of what happens when totality occurs. This was from October 21st, 2017. So what you're seeing is the moon right now is going over the face of the sun. Do you see how this beam is getting a little bit smaller here? This is called the diamond ring effect. So it looks like, your teachers who are married, it looks like the diamond that's on their finger. There's your diamond ring effect, and now we have the total solar eclipse at that point. I want to show you something else here. Oops, I got back too far. Here is the difference between a solar and a lunar eclipse. I think I need to press play here. If this, okay, yep, here it comes. Okay, so watch this. Oh, is it not moving? Oh, there it goes. Okay. So, during a total solar eclipse, here's the sun out here, there's the moon shadow over the earth, and then it goes away. So you only have, for us in Texas, about 4 minutes for that to occur. Now, the moon keeps going around, and what you'll see 6 months later, somewhere on the earth, is a total lunar eclipse when if you're on the first surface of the moon, they go into our shadow. So the sun is still out here, and now you have that. That's 6 months later. But why does this happen? So I have this model here, and this is where I need some people to help me. But let's start with this first. So I just want to explain what's happening. So here's what's going to happen in a week and a half. Here's the sun, here's the moon, here's the earth. Do we all know that the earth goes around the sun, right? That's pretty easy. Did we learn that in kindergarten, or did we learn that in first grade? Okay. We also know that the moon travels around the earth. So both of these occur at the same time. I can't really do it with just one hand, but you guys get the idea, right? So on this day, the sun, the moon, and the earth align. So here's my question for you. Why does this not happen every month, that we have a total solar eclipse, at least somewhere on the earth? I'll have you guys answer that question in a little bit. But also, just so you know, when you look at these images in your books, or when you see them on TV, the sun, the moon, and the earth, this is just a model that shows what it's like. If the sun was actually this size, the earth would be a half mile down the road, and it would be the size of an O on your keyboard. If we kept the earth this size, then this would be 29 feet in diameter, the size of the sun. So it would be almost to the roof, and this would be a half mile down the road. So let's show you what that looks like. Here's where I need your help. So I need two people. Okay, come on up, and let's get a boy in the back, right there. Come on up, right there. So here's what we're going to do. you are going to be, you want to be the Earth? Sure. Okay, so you are the Earth, okay? Way out there is the sunshine. So how far away is the moon really from the Earth? You're going to be the moon. What's your name?
Noah.
Noah. Everybody say hi to Noah.
Hi, Noah.
What's your name?
Elise.
Elise. Everybody say hi to Elise.
Hi, Elise.
So you're the moon. Let's see how far away the moon really is. So you have to walk away from us. Walk backwards. Don't worry, you're not going to hit Roger. Roger's going to make sure he doesn't hit you, but you're going to keep going until I tell you to stop. Because this is actually how far away the moon is, if we could put this in our school books, and you could actually see how far away it really is. You got to keep walking. Did you guys know, okay, slow down, and stop. Did you know that the moon is actually this far away from the Earth?
No.
Can you walk to the right a little bit? Kind of travel around the Earth? Go to the left, keep going? This is what the rotation of the moon looks like. It's really far away. Good job. You can stop and come back up. Thank you so much, you guys. I appreciate it. Do you want to help me, Noah? Do you want to bring that back together for me? Okay, you got it? There you go, Noah. Okay. So during a solar eclipse, the moon blocks out the sun's light. So why is there a difference? First of all, total eclipse, I showed you that already in the picture. The partial eclipse is what we're going to see. The annular eclipse just happened last October. Well, the moon, as it moves away, and I showed you how far away it is, there are times that it's actually a little closer to the Earth, and there are times that it's a little farther away. So when it's farther away, that's called apogee, and that's a Latin word for far, or perigee, which is close to the Earth. When the moon is at apogee, it does not cover the entire face of the sun. When it's at perigee, it does. So the annular eclipse occurred when it was farther away. So this is what it looked like in October if you were in the path of the eclipse. Again, annular means it's a Latin word for ring around the sun. But here's what's incredible about seeing a total solar eclipse. The moon is 400 times smaller than the sun. But the sun is 400 times farther away. So it actually, from our eyes, when we look up at it, they both appear exactly the same size. And that's why we get an eclipse. So let me ask this question. Why don't we get one every month? Let me ask you guys this, because I know you guys had a few people who raised their hands. So come on up, just a couple people. Yes, you in the purple, you in the blue, and we'll do someone in the close up. Yes, in green. So the question is, why, if this is correct, so we know that model's not correct in size, but if the moon goes around the Earth, now we know that the Earth is tilted 23.5 degrees, but if this is true, why do we not get a total solar eclipse every month? Okay, what's your answer?
Because then it would always be dark sometimes. It would be dark and we wouldn't have any light.
Okay, now that's true. That's a great point. What's your name?
Arav.
Arav, that's a great point. So, but the question is, okay, good job. You can sit down now. The question is, why don't we get one every 30 days? Go ahead. What's your name?
McKenna.
McKenna, what's your answer?
I think it's because if we would get one every month, it wouldn't be as rare, and that's not.
Yeah, no, that's a great point. You know what? We would get bored of them. If we had one every month, it would not be a big deal. But this is a big deal. It's happening in a week and a half. So great comment, but still doesn't say why we don't. Why don't we?
Because of the angle of the moon.
Oh my gosh. Oh my God. What is your name?
Alexandria.
Everybody give Alexandria a big round of applause. Go ahead, sit down. Everybody sit down. You can say, Alexandria, you can stay up with me. She talked about the angle of the moon. I'm going to tell you, there are people my age, and I am old and decrepit, but there are people my age who don't know that the moon is angled. Everybody look up. Let me show you what the moon looks like the way it goes down. It is actually at a 5-degree angle, a 5-degree tilt. So because of that tilt, it makes total solar eclipses rare. Great job. You are so smart. This is not how the moon travels around the Earth. It's at an angle, so it fluctuates, going like this. Good job. You can sit down now. Alexandria, that was brilliant. Great job. So when it lines up, it looks like this. So how rare is a total solar eclipse? Let's just talk about the state of Texas. The last Texas eclipse, you have to go back to 1878. The next American eclipse is in 2045. On average, you have to be in one spot, or for one spot, it happens, the total solar eclipse happens once every 375 years. The next one that goes over Friendswood in the year 2200. And this is what it looks like from space. You get a shadow. The moon just goes over a certain spot. Now again, the moon is smaller, so it's a smaller shadow. And then this is what it looks like paused from October, from the annular eclipse. Do you see the moon shadow on the Earth? It's pretty cool, right over the United States. What's also cool is if you're in the path of totality, as you all mentioned how it gets dark. It's dark above you, but if you look around the horizon, you're going to see sunsets at 360 degrees. So you see a sunset all around. So that's with the fisheye, so you can see the sunset color with the clear skies. Again, for Friendswood, this is what we're going to get. If you look south, who knows which direction we're in right now? Which way is south? Does anyone know? It's okay. We're going to pretend. Okay, so this is, okay, south. So if you look south and you're on a lawn chair, the partial eclipse is at 67 degrees up, and it's only going to cover 94% of the sun. But that's what it looks like from our vantage view. And so for our times on Monday, and so this is in a week and a half for you guys, on Monday you're going to be at school. 12:20 is when the partial eclipse begins. 1:40 is the maximum eclipse. That's when 94% of the sun is covered. What class do you guys have at 1:40? Switching? Switching? Math? The partial eclipse ends at 3:01. Are you guys still in school at 3:01? Yeah? No? Okay. I didn't get a really good answer from that, but that's okay. Thomas Edison in 1878. We were talking about the 1878 eclipse. Thomas Edison did an experiment. He wanted to know why the surface of the sun is 50,000 degrees. He wanted to know what the temperature of the corona is. That's the flare out, the feathery feature that you see. They found out years later that this is 2 million degrees. Thomas Edison did not get to find out it was 2 million degrees, because what he did in 1878 was he set up all this special equipment called a tassimeter. He set it up to measure the corona of the sun, and he set it up in a chicken coop. What he did not realize was that during a total solar eclipse, because it gets dark, you guys all had that right, that the chickens would go back to roost. And so while it got dark, all these chickens started invading this chicken coop, making a bunch of noise, hitting all the equipment, the tassimeter, and he had an experiment that failed because it got dark and the chickens thought it was nighttime and they went to go to bed. And so it messed up his experiment. Albert Einstein. Have you guys learned about Albert Einstein at all? Okay, so you know him. Oh, good. We like this. In 1911, Albert Einstein came up with the theory of what's called general relativity. And that's that large objects bend light. It was a theory. In 1919, during the total solar eclipse, there was some astronomers that actually tested this theory. So here's what his theory of general relativity is. Here's the sun. Light bends near the sun. It couldn't be proven because if we look outside, do we see any stars right now? No. It's too bright. Even with clouds, it's too bright. At nighttime, we see the stars. But during an eclipse, the sun is out, but it's dark. So what they found was that here's the sun, here's the earth. This is where we think the star is at night. They found that the actual location of the star was here during an eclipse. So yes, indeed, large objects like the sun, even the earth, bend light because of gravity. So it was proven because of an eclipse. So now you know one extra thing about Albert Einstein. Don't look at the sun. You guys are in school. I'm sure there's a lot of schools that are planning for this, and a lot of rooms that are like this with beautiful windows where you have views where you guys are going to want to look outside. Don't do it. The sun damages your eyes. But there are safe ways to see an eclipse. And guess what I have for you? I've worked out with your teachers to get you guys total solar eclipse glasses. So you have them on the day. And they're for KPRC 2, so you'll remember our visit. And then you also get to have the cool memory of seeing a partial eclipse. Not the total solar eclipse, but a partial eclipse. And that'll be coming up in a little bit. You can also make a pinhole camera. On the 14th October, as I was mentioning, that was a Saturday. And so a lot of kids weren't in school. A lot of kids didn't have solar eclipse glasses. And so you can make a pinhole camera. Put a little hole in foil. Do you guys like, who likes Reese's Puffs? Yes? Oh. It's good? You put a white sheet in. If the sun's over here, we were talking about the sun was over there. You put the sun over here. You look through this, and it'll show you the partial eclipse. It's very easy to make. Shape it, foil, white sheet there. You guys don't have to worry about that because you're in school and because we're giving you KPRC2 solar eclipse glasses. So the sun is 100 times bigger than the Earth, as we were mentioning. The sun is 93 million miles away from us. It takes 8 minutes and 20 seconds for the light of the sun to reach us. So we're always walking around in old light. When the sun sets and we see that last bit of sun go down, and we look over at the horizon and see a beautiful sunset, that light has actually been gone for 8 minutes and 20 seconds. So I am a meteorologist, so I do the weather on KPRC2. So if any of you guys ever wake up at 5 a.m. to 7 a.m., I'm on TV. There's someone shaking their head. If you watch online from 7 to about 9 a.m., I'm there also, and I forecast the weather. So actually, I don't talk a lot about science or about space unless it's a really cool event like the total solar eclipse. So what I do, to forecast the weather, I have to look at radar to show me where you're going to hear from 3 of your students whether they think it's going to rain today. And you look at radar to show where the rain is and where it isn't. You have satellite images where it shows where snow and clouds are. Here's another radar image. This is bad. Whenever there's a hook on a radar, that shows me that's a radar indicated tornado, and that's really bad. You also have recording stations. So what's the weather here in Friendswood at Cline Elementary? If we had a recording station on the top of your school, I would know the temperature, I'd know the humidity, I would know the wind speeds, I would know all of that. And I also have surface maps. So this is what I went to school for. How to interpret what high pressure and low pressure does. There's American models, there's European models, there's a whole bunch of different models, but models go out in time and they basically show what a computer thinks is going to happen. So here's the question today. Is it going to rain when you guys get out of school today? I'm going to show, or three of your students are going to show a weather model that shows rain in Friendswood after school. So is the model right or is the model wrong? And you're going to have 3 of your students show that. And you also have to look outside. This is a great room to look outside in because they got the sky right there. So I know if the rock is wet, it's raining. If the rock is swaying, it's windy. If the rock is hot, it's sunny. If the rock is cool, it's overcast. If the rock is white, it's snowing. If the rock is blue, it's cold. If the rock is gone, tornado! And then I make the graphics. So every morning when you watch me, if you ever do watch from 5 to 7 a.m. or your teachers watch or you watch online, the graphics that you see that are going to be on were made by me. And as I mentioned, the one graphic that I made for your school I messed up on, so hopefully it's fixed and it has the right name and it's spelled right. So hopefully that's correct if we got that fixed. But I make the graphics. How I do my job. I go in front of a green screen sometimes, and then I do the weather here. For a green screen, here's what's interesting about a green screen, and 3 of your students are going to find this out. If I brush my teeth on a green screen, the toothbrush is over here. If you brush your teeth in front of a mirror, the toothbrush is right in front of you. But on a green screen, it's over off at the side. So, could I have my 3 students, could I please get Gemma, Ethan, and Madeline? And Madeline is going first, right? And they are going to do the weather for you. They are going to give the weather for your city, the current temperatures for Friendswood and Cline Elementary. They are going, you want me to do it or you want to do it? Okay, they're going to tell you what they think if it's going to rain and show you what a model shows about rain. And then they're going to show you the forecast for today, for the rest of the day and tomorrow. Are you ready? Yeah. Okay, let's get you out in front. You're going to see yourself there. I'm going to switch out now, and I'm going to show all the students what you look like doing the weather. Okay, you're set. Go ahead and, do you remember how you start? Okay. So it does look, oh my gosh, so it does look like we have, you're right, we do have an issue with the internet. Okay, you're good. You're good. Just go ahead and, you're there. Perfect. But you see how there's a little bit of delay. So just get in the middle and go ahead and start. Okay.
Hi, my name is Madeline Prater, and I'm here at Cline Elementary to do the weather. Today, right now it is 57 degrees outside. And the wind speeds are low. After school today, there's going to be, or in the afternoon, there's going to be a chance of rain, and then it should clear up and by the night. And then it's going to be sunny tomorrow. Bye.
Good job. Can we have a big round of applause? That was Madeline. Ethan is next. Oh, I'm sorry. Okay, we're not. Oh, Ethan. That's right. Ethan's last. We've got, who do we have here? Gemma. Okay, Gemma, come on up. You're ready. You remember what you're doing, Gemma?
Yep.
Okay, go ahead.
Hi, my name's Gemma from Cline Elementary. Gemma from Cline Elementary School, and I'm here to tell the weather.
Weather knows there's nothing.
Today, the current temperature is 57 degrees, and the wind speeds are low. Expect a tiny bit of rain towards later in the evening, and it'll clear up at night. Bye. I thought I was supposed to do the last 3 days.
So you're right, because it's not showing up. It's not showing up. So good job. So I'm gonna talk about stay here, okay? Good job. Okay, wait for me. Okay, so let's get you set to the, okay, you're set. Now, okay, what you're gonna have to do though, you're gonna have a special thing you're gonna have to do. So do you see how that's not working? That is, so,
Look up there.
no, what you're going to have to do is go by memory of what you remember about the forecast. Can you do that?
I'll try.
Okay, go ahead. Go ahead and introduce yourself.
Hi, my name is Ethan Harris. I'm a third grader at Cline Elementary. Today's weather is 55 and it's cloudy. Tomorrow, expect sun. What the weather? With rain. Bye.
Oh.
I can't.
Yeah, you're right. Okay, everybody come on up. We got 2 minutes left. So you guys experienced something really tough. Okay, where did our other person go? Where did Madeline go? Come on up. Come on up, guys. Come on up. They did something very brave, because what you guys can't see is that computer is locked up. So the internet in here, we were told before we came in, is not great. And so what happened is they couldn't see the maps behind them. And so they were going blind. Now, for me, I know what the weather is. These guys don't know. And so can you give them a big round of applause? And honestly, can I tell you, here's what, this is an important life lesson. An important life lesson is that sometimes in life, you expect something to go a certain way, and it doesn't. And when that happens, how do you adjust? And they did great. How graceful did these two look, just standing there waiting for the map to go, and it didn't go? That's a lot of grace. And then how much personality just to say, hey, this isn't working, I can't see it, bye. I mean, that's a learning lesson. That's a great lesson to learn, because I put you guys, every school we do this to, we put you guys on the spot, and they have to do it, but the equipment works. You guys, I put you on the spot having to do a forecast. You didn't know the weather, and the equipment didn't work. So that was, then you're looking at me like, what do I do? And they were just so graceful. And it's live, right? Like we talked about. When it's live, we can't go back and do a take back. You guys, hey, that was tough. You guys did great. Can we give them another round of applause? We have 1 minute left. But let me interview these guys and just ask them about, because first of all, what it was like. So you went first. What was it like seeing yourself on TV?
It was scary.
Why?
I've never been on TV before, so it's just a first time experience.
Perfect. Okay, you guys. Are you guys ready to say goodbye to our audience? Everybody say goodbye. Roger's turning the camera around.